Hello, everybody. Today we are going to talk about perspective and the key terms you should know regarding it. Now, I do know that this can be a very complicated subject with lots of information, so make sure you are taking notes and really try to understand each aspect. Perspective. It is the art of rendering the visual effect of distance. It was created by the Florentine architect Filippo Brunelleschi in 1415. And it's how we draw objects that look solid, three-dimensional, and not flat. You are taking the three-dimensional world around you and drawing it on a two-dimensional piece of paper to give it the illusion of depth. Here is a brick drawn without perspective and a brick drawn with the use of perspective. The one on the right, the one using perspective, looks three-dimensional. It looks like it has depth. It's not only used to make the object appear to have dimensions, but also creates distance and a feeling of space. In these drawings, we feel like the train tracks are receding away from us. Eye level. It is the height of your eyes from the ground. Very straightforward. Even if you are looking down, it does not move. It is still the same distance from the ground. Even if you are looking up, your eye level is still the same distance from the ground. Even if you're sitting down, your eye level is all about the relation of where your eyes are to the ground. Once again, it doesn't matter if you are looking up or looking down, the eye level will always be level with your eyeballs. So I want you to imagine the room filling with water all the way up to your eyes. Where the water hits your eyes is eye level, right there. Everything below the surface is below eye level, and everything above the surface is above eye level. This is important because how you draw something will all depend on its relation to you. If you are standing up and a table is in front of you, chances are the table is below eye level. So as you can see here, you can see the top of the table. But if you were sitting on the ground, now your eye level is low to the ground. And that means you're underneath the table. And now you can see the bottom of the inside of the table. So when you are drawing, you always need to remember where your eye level is, because it will affect if you are seeing the top of something or the bottom of something. The horizon. This is the most important thing in perspective. The one thing, if you were to only understand one thing this entire semester, is what is the horizon? And it's where the sky meets the ground, right? Something you guys probably already knew, but it's an important fact you always have to keep at the front of your mind when doing perspective. In reality, the Earth is round. So really, you're not seeing the edge of the world here, but it's where the Earth curves away from you and eventually disappears out of sight. Fun fact, if you were standing on a beach and you could see the horizon in front of you, the average person can only see about 3 miles before the Earth curves beneath our view and vanishes. If the Earth were flat, we actually could see a lot farther. Think of it as continuous. Even if you were to go indoors and the walls were in the way, the horizon is still there. If your hand is in the way, the horizon is still there. Even if you can't actually see the point where the sky meets the ground, it is always there. And most importantly, every drawing has only one horizon. Only one. Even if it's off the page, even if you can't see it, it is still there. What this all means ultimately is that the horizon is the eye level of the artist. These are two words I may use interchangeably because the horizon will always appear to be at eye level. If you are looking straight ahead, up, or down, the horizon will always be at eye level. Doesn't matter where you're looking. If you are standing along train tracks, the horizon will be at eye level. If you were laying down on those train tracks, the horizon will be at eye level. If you were standing in your living room, the horizon will be at eye level. If you were standing on a mountain, the horizon will be at eye level. The horizon is always at your eye level. I want you to look around the room you're in right now. Ask yourself, where is my eye level? So imagine that room filled with water all the way up to your eyes, like I said before. Maybe even stick out your hand so it's floating on the surface of the water. That is where your eye level is. You can also imagine taking a hula hoop, putting it around your head so that's floating on the surface of the water, kind of like the rings of Saturn that's floating around your head. That hula hoop is the horizon line. If you imagine looking at it, turning your head left and right, no matter where you look, you can see that hula hoop right there. No matter if you look up or down, the horizon is still floating there on the surface of the water. And that is where your horizon is. You have to visualize not only what the room looks like around you, but what is outside your room. As I said, even if you can't actually see the real horizon where the sky meets the ground, you know it's still out there because it's always going to be at your eye level. So these two terms are interchangeable. Sometimes I may say horizon line or HL. Sometimes I may say eye level or write out EL. And remember, if there is only one thing I want you to learn this semester, is that every single drawing has one and only one horizon line. Okay, parallel lines. Something you should probably know already at this point. It's when you have two or more lines that extend in the same direction and remain the same distance apart. These sets of lines are parallel. Receding lines. They are lines parallel to each other that gradually move away from the viewer. The common example is train tracks. If you were to look from above at train tracks, you know that the metal tracks are always parallel to each other. You know, it wouldn't work if they were all of a sudden closer to each other or farther away, the train would fall off the track. So now imagine you're standing on train tracks on a straight line and you look down and you know the rails are parallel, right? You know that's always true. But if you were to look straight ahead, it would look like as they're getting farther away that they're getting closer together. What you must always remember that even though they may not look like it from this angle, the lines are still parallel. In reality, they are parallel. But because they are receding, they look like they're getting closer together. That is the illusion of perspective. I will often ask you to look for parallel or receding lines in a picture, and this is what I'm talking about. Lines that are parallel and moving away from the viewer. Vanishing point. It is the point where receding parallel lines appear to meet. All parallel receding lines in a perspective drawing, if extended far enough back in the distance, will all meet at the same point. This is called the vanishing point. This is very, very important for you to understand. All lines that are parallel and receding will eventually converge at the same vanishing point. See that? Every single one of these lines here, they're all parallel to those train tracks. So they're all going to converge at that same vanishing point. The point where these receding lines will appear to meet is on the horizon line. Vanishing points are always on the horizon line. Remember, the horizon is where objects appear to disappear in the distance. So that includes our receding lines too. The vanishing point is always, always on the horizon. Remember, when I'm talking about parallel lines, that I'm talking about receding lines. Horizontal lines that are parallel to the horizon or parallel to you so they are not receding, they will never converge, and so they'll never have a vanishing point. They will never meet. Vertical lines that are parallel to us, like these telephone poles or these fences, they're not receding, so they will never converge, so there is no vanishing point. They will never meet. The general rule is that lines that are parallel to your face or the viewer will never converge. It's really, really important to know when I'm talking about parallel receding lines and parallel lines that are not receding. Station point. It is the point where the artist is standing. When you are drawing perspective, it's important to know where you are at all times in your drawing, because everything in perspective is relative to where you are. And this can't change. You can't start a drawing of a lamp, for example, sitting on the floor, and then halfway through stand up and move to the other side of the room. The lamp will look totally different. You have to remain stationed or fixed. Line of sight. It's where you are looking. And that's really important to know. Imagine you were to stick a pencil out of the spot between your eyes, almost kind of like a unicorn, but like right between your eyes, and you turn your head. Notice how that pencil moves, so that no matter where you look, it turns with you. That is your line of sight. It is where you are directly looking. Cone of vision. So we have a 60-degree angle of undistorted vision. Even though our line of sight is straight ahead, we have an approximate 60-degree angle of undistorted vision that extends as an imaginary cone from your eyes forward. This is called the cone of vision or field of vision. You can kind of imagine it like a 3D cone sticking out the front of your head. It doesn't matter if you're looking up, looking down, or straight ahead, it will follow where you are looking. Really, what we're talking about is your peripheral vision. If your eyeballs are looking straight ahead and you try to look at something out of the corner of your eye, it can be hard to see, right? It's pretty distorted. That's what the cone of vision is. Everything inside this 60-degree angle you can see pretty well. But if you try to look too far into your peripherals, outside of that 60-degree angle, objects become blurred and distorted. So let's put that all together. Station point is where you are standing. Your eye level is the height of your eyes from the ground, or the horizon line. Since you are looking straight ahead, your line of sight is at your eye level, or horizon line. And your cone of vision, or the undistorted area you can see, is a 60-degree angle area in front of you. If you are looking up, your eye level or horizon line hasn't changed. But now your line of sight is facing upwards. And your cone of vision, or the undistorted area you can see, is a 60-degree area in front of where you are looking. So the cone of vision moves with the line of sight. It's really just talking about that area that you can see well without distortion. If you're looking down, your eye level or horizon line hasn't changed, but your line of sight is now facing downwards, and your cone of vision is in front of where you are looking down at. Picture plane. It's an imaginary glass window the artist looks through. So imagine you are holding a piece of glass in front of your face. If you were to then take a Sharpie and trace the outlines of what you would see onto the glass, the result would be a perspective drawing. So in reality, our piece of paper represents that glass, and what we are drawing is within our picture plane. This may seem like a silly thing to explain, but sometimes we may need a piece of paper that is larger than what the actual drawing will be. In many perspective drawings, your vanishing points or horizon line may be outside of your picture plane. So I will usually have you start with drawing a picture plane or a box on your page, and your drawing will be within that box, leaving room on the outside for your vanishing points or anything else. Diminution. Objects appear to become smaller as they recede. One of the key aspects of perspective is that the farther things are away from us, the smaller they appear. That is called diminution. The train tracks appear smaller the further they get away from us. Your hand is huge because it's close to your face. It may even look the same size as a person standing several feet away from you. And the people in the distance look even smaller and smaller as they get farther away. The cars look smaller and smaller as they recede. And the train cars look smaller and smaller as they recede. Even more specifically, the closer objects are to the horizon, the smaller they become. Notice in all of these pictures where you can see the horizon that the closer these objects get to the horizon, the smaller they are. Because they are getting to that point where they eventually will disappear into the distance as the Earth curves away from you. Notice the tile floor in this drawing. The tiles closer to us are larger. The tiles closer to the horizon appear smaller. The banister posts that are closer to us are larger, and the farther away they get from us and closer to the horizon they get, the smaller they appear. Eventually, if they got close enough to the horizon, they would eventually disappear. Foreshortening. Another term you may have heard, objects parallel to you show their maximum size, and as they turn away from you, they appear shorter. This pencil, for example, as he holds it parallel to its face, its full length. You can see that is the height of the pencil. But as he turns it away from him, as he rotates that pencil, it starts to appear shorter and shorter. And it's not actually getting shorter, but the fact that it appears shorter or looks shorter is called foreshortening. Eventually, if you turn that pencil away enough, all you would see is the dot of the eraser. Try it yourself. Hold up your pencil in front of your face and rotate it. Remember, you kind of have to forget that the pencil isn't actually changing size, but it does appear shorter if you were to measure a line from the top of the pencil to the bottom of the pencil. Convergence is diminution plus foreshortening, which really means as objects recede away from us, they will get smaller and smaller until they eventually meet at one point. This picket fence, which when viewed straight on, it is parallel to us, appear all equal in height and spacing. But if the observer was to turn, so he's looking at that fence at an angle, the top and bottom lines, if extended far enough, appear to converge. Notice that this convergence relates directly to the diminution of the pickets as they recede. Furthermore, the true length of the fence no longer appears, but is instead foreshortened. We can see a whole lot more of this fence than we could when you were looking at it straight on, because it is foreshortened and appears shorter. And not only does the height of the picket's fence get smaller as it recedes, but the width of the object and the spacing in between the pickets will get smaller. That's really important to understand. Everything is getting smaller, both the object and the spacing between them. Overlap. This one's a little obvious, but it's worth mentioning. One of the best ways of achieving a sense of depth and space in a drawing is by having objects overlap. Notice how confusing the depth is on the drawing on the right where there is no overlap. Now, you can't tell what's in front of one another, but if you start overlapping and put some things in front of the other, that really just helps emphasize that illusion of depth that we're trying to create. Atmospheric perspective. Objects in the distance are less defined. It's another way to create depth. And what atmospheric perspective is the air is actually filled with little particles of matter. And as things get farther away from us, it becomes harder to see them because of the buildup of all these particles. The result is it makes objects that are far away appear less defined, lighter, and less saturated. And this actually ends up making things a lot easier for us because it makes a lot less work for us. It forces us to focus our attention on detail in the objects that are closer to us, and we can kind of forget the ones that are farther away. All of these factors combine to create an optical illusion and a perceived breaking of the picture plane to approximate a binocular vision of the 3D world on a 2D surface, which ultimately means this is how we create the illusion of depth in a drawing. So I want to recap some of the more important terms that you absolutely must understand here. Where is the horizon line? Do you remember? Where is it? It is where the sky meets the ground and where objects will disappear out of sight. It is continuous. Even if you go indoors and the walls are in the way, the horizon is still there. Or if trees or mountains are in the way, it is still there. Even if you are looking up at the sky and you can't see it, it is always there. Most importantly, every drawing has one and only one horizon line. Even if it's off the page, even if you can't see it, it still exists. Where is the eye level? At the horizon. It is always at the horizon. You can use these terms almost interchangeably. Your eye level is all about the relation of where your eyes are to the ground. And the horizon will always appear directly in front of your eyes. Remember to imagine that room filled with water all the way up to your eyeballs. Everything below the surface is below eye level, and everything above the surface is above eye level. Once again, it doesn't matter where you're looking. It doesn't matter if you're looking up or down. It doesn't matter if you're sitting on the floor or on a mountain. The horizon will always be at eye level. What are receding lines? Receding lines are lines that are parallel to each other and are gradually moving away from the viewer. I'm going to talk about receding lines a lot, so it is very important that you understand what they are. All these lines in reality would be parallel, and in our drawing, they are receding away. And it's important to know what lines are not receding. All of the horizontal and vertical lines in this picture are parallel to us, the viewer, and they are not receding away from us, so they will never converge. Where do receding lines converge? At a vanishing point. All receding lines that are in nature parallel to each other, if continued far enough, will meet at one point. This is the point where they would disappear from sight, and that is why we call it the vanishing point. It's where things disappear. Where can you find the vanishing point? The vanishing point is always on the horizon. Now, there are some exceptions to this rule, which I will talk about later, but for now, I want you to remember that when you are trying to figure out where to put your vanishing point, that it will be somewhere on the horizon. I want to reiterate, all receding lines that are in nature parallel to each other, if continued far enough, will eventually meet at the same point. So all these lines here are parallel. They meet at a vanishing point. And notice that I said that lines that are parallel to each other. So, what if there are multiple sets of different parallel lines? Because not every single line in existence is always going to be parallel to each other. This brick has another set of parallel lines that run along the width of this brick. Then those lines will converge at a different vanishing point on the horizon. Parallel receding lines along the length of the brick, if extended far enough, will converge at a vanishing point to the left, and the parallel lines receding along the width of this brick, if extended far enough, will converge at a vanishing point to the right. Now, we will talk about this later, so don't worry about it yet, but I want you to be aware that when I say parallel, I'm only talking about lines that are parallel to each other. So if there are multiple sets of parallel lines, there can be several different vanishing points on the horizon. Where is your line of sight? It is where you are looking. It's important to know where you're looking at all times. If you're looking straight ahead, your line of sight will be straight ahead. If you're looking up, your line of sight will be up. And if you're looking down, your line of sight will be down. And notice how the horizon line and eye level did not change in any of these. What happens to objects as they recede away from us? This is the big thing. They appear smaller. Understanding this is the key to making believable perspective drawings. Objects that are farther away from us appear smaller. Each of these telephone poles get progressively smaller as they get farther away from us, otherwise known as diminution. Eventually, if you were to keep drawing them all the way back, they would disappear where they converge on the horizon, which is their vanishing point. This also means that the space between them will get progressively smaller and smaller. And that's it. That is the core basic vocabulary of perspective. It is so important that you understand each of these terms and what they mean. Perspective can be extremely complicated, believe me, I know, and we have a lot of information to cover. We will be building on this for the next several weeks. But if you understand these basic starting concepts, it will make everything a lot easier for you as we move forward, because I want each and every one of you to understand this.